So the concentration that we get over here is the mass by volume. This is the mass, this is the percentage, the mass by volume. Now, it's important to note that just to see the difference between those two glasswares, the volumetric flask and the graduated cylinder. Now, the graduated cylinder is not that accurate. And the reason why it's not that accurate, because let's say, for example, if you want to do the same steps, but now instead of using a bottle, you're going to go ahead and use the graduated cylinder and fill this up. Here, this one tells you how inaccurate this graduated cylinder is. So we're going to go ahead and measure whatever mass of solid we need. We're going to put it in that volumetric flask. And then you know that this volumetric flask now has a capacity of 250 mils, and this is the mark of the 250 mils. Well, if you get a graduated cylinder and fill it to the 250 mil mark, and then dump that liquid in there, you're going to see that the amount of the liquid in the graduated cylinder is going to be more than the 250. So in order to have the right volume, you have to fill to the mark. And notice here, they use this liquid, they fill to the mark, and see how much left they had. They had around like, how much? Around like 45 mils left. So that tells you that the graduated cylinder is not very accurate in order to measure the volumes of liquid. Same thing, I mean, there are beakers in there that are also graduated. These are also not accurate in measuring the volumes of the liquid. So if you want a glassware that is accurate, this is the volumetric flask. There are other glasswares that I'm going to show you in this chapter that are accurate, which is called a burette. So you can either use a burette or you can use a volumetric flask. Those they should have the right or the accurate volume of liquid. They show accurate volume of liquid. So let's answer this question. Describe how to prepare 500 ml of 0.250 molar NaCl solution. Okay, so the first thing they are asking me here, they want us to describe how to prepare a 500 ml of 0.250 molar NaCl solution. So since NaCl is a solid, right? We know that this is a solid. If it's a solid, we need to mass the solid. So to get the mass of the solid, you have to put it in a formula and get the mass of the solid by the use of the volume and the concentration. So if I know the volume, if I know the concentration, I can get the number of moles. It's as in the number before. Once I get the number of moles in there and I know the molecular weight, I want to get the mass, because you want to get the mass, right? To prepare sodium chloride solution of this concentration, you need the mass, because notice here, the first step is we need to know information about the mass of our solid. So from the given, you need to get the mass of the solid. So we're going to go ahead and arrange this. Number of moles is equal to the concentration multiplied by the volume. We already know the concentration, which is 0.250 molar. The volume here is 500 mils, so it's going to be 500 times 10 to the minus 3 liters. And the number of moles now is equal to 125 moles. Knowing the number of moles, and we already know the molecular weight of NaCl, which is, let's calculate it, the molecular weight of NaCl. This is the molecular weight of sodium, look at the periodic table, plus the molecular weight of chlorine, and that's supposed to be 58.4 grams per mole, okay? So now we're going to go ahead and substitute that. We already calculated the number of moles, and we're going to multiply it by the 58.4 grams per mole. And now I can get the mass, which is 730 grams of NaCl. So what's my first step now in prepping that NaCl solution? Weighing the 7.30 grams of NaCl. So we would need to weigh 7.30 grams of NaCl. And then see what we did up there? We weighed it, we put it in a volumetric flask, we added a little bit of water so that we dissolve the solid completely, and then we topped it off until we reached the mark. And this is going to be our concentration. And this is what we're going to do. We're going to add it to the 500 ml volumetric flask. We're going to add some water to it until all the solid dissolves, and then fill the volumetric flask to the mark, to the 500 mark, and this is going to be the accurate concentration. So now our solution concentration will be 0.250 molar concentration. Okay. Another method in order to prep also and get the accurate volume of liquids is to use a pipette. So this is called a pipette in there. A pipette looks like this. This is a volumetric pipette. Volumetric pipette, similar to the V flask, it does have a mark. And the mark tells us the volume of the volumetric pipette. Volumetric pipettes can be 1 mil, 2 mils, 10 mils, 20 mils, 30 mils, 50 mils, and so forth. Okay, and they are accurate because they do have a mark, and if you fill them to the mark, this is going to be the volume depending on the volume of the volumetric pipette. So in this part here, we want to prepare a solution of different concentrations. So this is called the dilution method. So what is a dilution method? A dilution method is whenever you have a solution of a certain concentration, and then you want to prepare another solution from it that has a lower concentration. So this is called the dilution method. So you start with your solution that has a C1 concentration, and then you end up having another solution that has a C2 concentration in there. The C2 concentration is going to be less than the C1 concentration because you prep the C2 from the C1. Okay? So basically what you do over here is you start with your solution that has a high concentration, and you take whatever you need to take from that in order to prep another solution of a lower concentration. So this is called the dilution method, and it does have a formula. What is the formula? It's C1V1 is equal to C2V2, or M1V1 is equal to M2V2. We agreed that C and M are the same. This is the concentration. So you always start with the concentration of the concentrated solution. So C1 is the concentration of the concentrated solution. V1 is the volume of the concentrated solution. And then C2 is the concentration of the diluted solution that you want to prepare. V2 is the volume of the diluted solution that you want to prepare there. One of these is going to be an unknown. And most probably it is V1, because they would tell you, okay, we have a solution of 2 molar concentration, and we want to prep a solution of 1 molar concentration in certain amount of volume. So how much should we take from this one? So this means that the V1 is going to be the unknown that you would need to find out. Okay, so let's have an example. How for these problems, it's easily detected that it is a dilution problem. If you start with a certain concentration and they ask you about a solution of another concentration. So here, describe how to prepare 250 ml of 0.5 molar HCl from a 1.5 molar HCl. So see how the problem is written. You are starting with a high concentration solution of HCl, right? And you want to prep a low concentration solution of the same thing, of HCl. So this is called a dilution problem, And the dilution problem, always, you lay down the formula, which is C1V1 is equal to C2V2. Always make sure the first concentration and volume are for your concentrated solution, okay? And the C2V2 is for your diluted solution, okay? So I'm starting with C1 to be 1.5 molar, okay? Now, I don't know how much I'm going to take from that 1.5 molar. I have no idea how much. But what I know is that I am preparing a solution that is low in concentration, which is 0.5, this is C2 molar, and the total volume of that low concentration is 250. It's going to be in 250 mils. I have to give you the volume of your final prepared solution and the concentration of your final prepared solution. This one is the diluted one. And then I would ask you over here, okay, how much are you going to take out? This is the V1. Take out from the original concentrated solution to prepare another solution with that volume and that concentration. So now the V1 is going to be my unknown. Okay, so V1 is going to be my unknown in there. And we're going to do a relationship in there, which we can do V1 is equal to C2 V2 over C1. Okay, so you just do a relationship in there. How did I do it? I want the V1, right? So I divided by C1 here, I divided by C1 there, C1 and C1 goes out, and then I have a relationship between V1 and C2, V2 and C1. And then we're going to go ahead and substitute. It's going to be 0.500 molar times 250 mils divided by 1.50 molar. And that is going to be 83.3 mils. It has to make sense, you guys. It does have to make sense in there. So what does this say? This say that from the solution of 1.5 molar, I'm going to take 83.3 mils of this solution, okay? And then I am going to add it to a volumetric flask. So this is going to be my volumetric flask. So that's going to be my volumetric flask. I'm going to add 83.3 mils of the concentrated HCl. It's going to be of 1.5 molar HCl. Now, right now it's going to be 83.3 mils, but the total volume that I want is 250. So I'm just going to fill to the mark. I'm going to fill this to the mark with water. So I'm going to fill the rest with water until I reach the 250 mil mark. Okay? And then after I do this, then I will have a solution that has a concentration of 0.5 molar. Okay, guys? So this is how the dilution is prepped. So whatever volume you get from the high concentration solution, you add it to your V flask, and then you top it off with with pure water, or with we say it's pure water or distilled water. So you top it up with pure or distilled water until you reach the desired volume of your diluted solution, and the desired volume here is 250. The 1.5 molar is your actual concentrated solution, which we call it a stock solution. So a stock solution is a solution that is concentrated, and from that stock solution, we want to prepare a diluted solution. Okay? Let's have another example. So when we say a solution is prepared is just an indication for us that this is a dilution problem there. So you have a high concentrated solution, and you want to prepare a low concentrated solution. Okay? So a solution is prepared by adding 250 mils of 1.3 molar aluminum chloride solution to a flask, and then adding enough water to bring the final volume to 200 mils. What is the molarity of the solution? Great. So our concentrated solution is 1.3 molar. So I am given my concentrated solution is 1.3 molar. It's telling me that it took 25 mils from that concentrated solution. So now I have V1, now I have C1. And it tells me that, okay, I am adding enough water to bring the final volume to 200 mils. So your final volume is 200 mils. What is your concentration, your diluted concentration? C2 is the diluted concentration. So whatever concentration you get, guys, it's going to be less than 1.3 molar because it's now diluted. You started with a stock solution of a high concentration, and you took 25 mils from that. You added it to the flask. You topped it to 200 mils. You want to know now what is its new concentration. So we're going to go ahead and rearrange. So I'm going to divide by V2 here. I'm going to divide by V2 over there just to get the C2. So that is my formula. C2 is equal to C1 V1 divided by V2. C1 is 1.30 molar. V1 is 25.0 mils. And then V2 is 200.0 mils. Okay. Pretty much this is it. So we can go ahead and do our calculation in there, and the mils and the mils will cancel out, and my concentration now is 0.163 molar. It does have to make sense, you guys. It does have to make sense because 0.163 molar is less than 1.3 molar. So C1 is always, this is the stock solution. It needs to be more concentrated than the diluted solution. So that is going to be my concentration there, which is in molars, meaning moles per liter. Okay. Another example. This one is similar to number 19 in your homework. And with this one, it says how many mils of 6.00 molar HCl are needed to prepare that much volume of this much concentration of HCl. See, this is again a dilution problem because I'm starting with a high concentration HCl. I'm ending up with a low concentration of the same solution, HCl, in there. And now I need the volume. So now I need V1 in there. So I know that I have a solution of 6 molar concentration. I don't know how much I took from that, but I took X volume of this to make another solution that has a volume of 1500 and its concentration now is 0.2 molar. So do C1 V1 equals C2 V2. We're going to divide by C1 here, divide by C1 in there. So our formula V1 is equal to C2 V2 over C1. And you go ahead and you do your substitution in there. So C2 is 0.2. V2 is 1500 mils and C1 is 6.00 molar. Molar and molar cancel out and you are left with the mils in there. Okay. They are asking about the volume in mils, so you just keep it in mils. If they want the volume in liter, so you have to change that into liter by simply dividing by 100 or multiplying by 10 to the negative 3. Okay, so another topic, concentration of and the stoichiometry. So what is stoichiometry? Stoichiometry is whatever we've been talking about, a number of moles in a regular equation. So if I am working with HCl plus NaOH, the stoichiometry for this is 1 mole of HCl reacts with 1 mole of NaOH. So the number of moles there in the equation, this is your stoichiometry. So 1 mole of HCl reacts with 1 mole of NaOH, and you are going to get 1 mole of sodium chloride and 1 mole of water. So let's have this example here. So here it's asking how many mils of 0.100 molar HCl. Okay, so I'm starting with 0.01 molar HCl would exactly react with 25 mils of that much concentration NaOH solution. Notice here, this is not a dilution problem because I'm going from HCl to NaOH. These are two separate solutions, not the same solution there. So I would need the equation. I know that for every 1 mole of HCl, I'm reacting it with 1 mole of NaOH. They want the volume of the HCl. And they gave me the concentration of the HCl. And now they gave me the concentration and the volume of the NaOH. So, and they want the volume of the HCl. So let's see, what do we need to find in there? So we need to find the volume, right? How can we get the volume? Well, they gave me the concentration, and I know that there's a direct relationship between the concentration, the number of moles, and the volume, right? So I don't know the volume of the HCl. This is the concentration of HCl. This means that I need to get the volume of the HCl that they are asking me about, and the number of moles. I don't know what's the number of moles of HCl. But since they gave me the concentration and the volume, I can get the number of moles from here. And then I can relate the number of moles of NaOH to the number of moles of HCl in this equation. So let's get the number of moles of NaOH first, and then relate it to the number of moles of HCl so that we can find the volume of the HCl. We're given the concentration of HCl in there. So we're going to find now the number of moles of HCl, and to do this, we need to find the number of moles of NaOH. Okay? So to get the number of moles of NaOH, we're going to do exactly the same thing there. We are going to calculate the number of moles of NaOH. So we're going to do the concentration of NaOH, because after all, to get the number of moles, you need the concentration, right? So that is going to be the number of moles of NaOH divided by the volume of NaOH. Okay, that's capital N. Okay, so this means that the number of moles of NaOH is equal to the concentration of NaOH multiplied by the volume of NaOH. So the concentration of NaOH is given 0.125 molar, and the volume is given, remember, volume has to be in liters. So that's going to be 10 to the minus 3 liters. Guys, if you keep it in mils, remember that the molar is moles per liter. So you cannot keep your volume in mils. You have to change your volume into liters. Liter and liter cancel out, and then I get my number of moles, which is 0.00313 moles of NaOH. Okay, so I got my moles of NaOH. Can't I change the moles of NaOH to moles of HCl? Yes, I can, because I know that let's start with 0.00313 moles of NaOH. Okay, I want to change this to moles of the of HCl. I know that 1 mole of HCl reacts with 1 mole of NaOH based on the equation that you have up there. Okay, based on this equation, 1 mole of HCl reacts with 1 mole of NaOH there. If there is different number of moles, you would need to report this in this equation. Okay, so the moles of NaOH and the moles of NaOH goes away, and then I would end up having 0.00313 moles of HCl. Good? So you got the moles of HCl in there. So once you get the moles of HCl, we're just going to go ahead and plug them in here. So you now have the moles of the HCl, which is 0.00313 moles, right? This is the moles of the HCl there. We have the concentration, so we can easily get the volume of HCl. So the volume of HCl now is equal to the number of moles of HCl, which we already calculated, divided by the concentration of HCl that we already have it given, which is 0.1 there. So that is equal to 0.00313 moles divided by the concentration, which is 0.100 molar, which is, take it out, moles per liter. So you know that your volume that you are getting now is going to be in liters, okay? So that is going to be 0.0313 liters in there. They want the volume in mils, you guys. So if they want the volume in mils, then we're going to go ahead and multiply by 1,000. So it's going to be 1, 2, and 3. So it's going to be 31.3 mils. Okay, and that is going to be your volume needed. So you need 31.3 mils of this concentration in there, and this is going to exactly react with 25 mils of that much concentration solution. So see the steps that we did there. They gave you the complete information that you need about sodium hydroxide. So you can get the number of moles of sodium hydroxide. Once you get the number of moles of sodium hydroxide, you put it in this equation. You relate the moles of the NaOH with the moles of the HCl. Once you know the moles of the HCl, you have the concentration of the HCl, you can calculate the volume of HCl.